Okay, the first example of division of polynomials that we want to do is one that is about long division of polynomials. So you see the problem stated. Use long division to find the quotient and remainder for 6x squared plus 7x minus 5 divided by 3x plus 5. Before going any further, I'd like to remind you that you can pause this video at any time to write down the information you need to, or to even work ahead. Remember, the way we start a problem of long division is we write down the divisor and then our long division symbol, and what we're dividing into, the dividend, goes underneath the long division symbol. Now, as we get started on this problem, what I'd first like to do is kind of refer to what it would look like if we were doing some kind of division with whole numbers. Suppose we were dividing, say, 115 into, let's say, 583. The way we begin this is we ask ourselves, how many times will the biggest part of this divisor divide into the biggest part of the dividend? And in this case, we would say 5, or 5 times 1 gives us 5, and so we write our 5 here. But now, when we do our multiplication, we don't just say 5 times 1, we say 5 times the entire divisor, which of course here is 575. After we do that multiplication, we do our subtraction. In this case, we get 8, and we know that we're finished with this division because the remainder at this stage is smaller than the divisor. Well, with polynomials, it's similar, but the idea of largest part has to do with the degree of the polynomial. So the largest part of the divisor is the term of largest degree. The largest part of the dividend is the term of highest degree of the dividend. So we're going to compare the 3x to the 6x squared, and we ask the question, what times 3x will create 6x squared? Or that is another way of asking, how many times does 3x go into 6x squared? Well, of course, it takes 2x times 3x to create 6x squared. And notice I put the 2x in a column created by the dividend of x's. Now, as we did with this problem, we need to make sure that this 2x multiplies the whole divisor. So what we're really doing is saying, what is the result of 2x times 3x plus 5? Now, we can see that's simply a distribution problem, but sometimes it helps us out to write it in this fashion. So we'll be saying the 2x times the 3x, which of course gives us 6x squared, and we write that here. And then the 2x times the 5, or looking at it from here, 2x times the 5 gives us a 10x. And then we're prepared to do our subtraction. And of course, the subtraction that we're doing in this case is the top polynomial subtract the bottom polynomial. Well, the top polynomial is 6x squared plus 7x minus 5. We're subtracting the bottom polynomial, 6x squared plus 10x. Now we know this is going to create a 6x squared subtract 6x squared, which will be 0. So that's the 6x squared subtract 6x squared we see here. And then we know that's going to create a 7x subtract a 10x. Okay, 7x subtract a 10x. Well, of course, that's negative 3x. That's the 7x subtract 10x here. And so what we're going to be writing then is the 6x squared subtract the 6x squared, which is 0. The 7x subtract the 10x, which is negative 3x. Now, that would have also left us over in this position, the minus 5 left over here. By the way, that was a 10. And the minus 5, we have nothing related over here that we're subtracting, so that it leaves that negative 3x minus 5. So that's the idea of bringing down the minus 5. Okay, let's clear a little space over here before we go further. Let me do some erasing. This is a little bit slow, isn't it? Now we've got some extra spots here, but okay, let's continue with our problem. Now, remember what we do next is we compare, we decide whether we're finished with our division, so we compare to see whether this is smaller than this, and then we compare that by degrees. Well, the degree here is 1, the degree here is 1, it's not smaller, so we continue. So we think of the same problem, the same issue we did a while ago. What do we multiply this 3x by to create this negative 3x? And of course that's minus or negative 1. And we put that minus 1 or that negative 1 in the column of constants. And then we take that negative 1 and we multiply the whole divisor with that negative 1, but we do it a term at a time. So negative 1 times 3x creates a minus or a negative 3x. Negative 1 times positive 5 creates a negative 5. And then we're prepared to subtract. Of course, in this case, we see this polynomial and this polynomial are the same, so when we subtract, we actually get 0. But we could think of it, as we did a moment ago, is the top polynomial, negative 3x minus 5, subtract the bottom polynomial, negative 3x minus 5. Okay, well, of course, negative 3x minus negative 3x is negative 3x plus 3x. And of course that's 0. That's negative 3x subtract negative 3x gives us 0. And the negative 5 we have here, subtract the negative 5 we have here, which becomes plus 5, is how we read negative 5 subtract negative 5, and of course that is also 0. So a result here is 0. That becomes a remainder. Now, of course, with a remainder of 0, we know we're finished. Let's consider, well, of course, the way we would write that answer is by saying we were asked for the quotient and the remainder, and we record that quotient and remainder. Now, let's also remember how we would check a problem that has a remainder of 0. The check of such a problem says that we take the divisor times the quotient. It should be equal to the dividend. Here we see, of course, our divisor was 3x plus 5. Our quotient was 2x minus 1. Our dividend is 6x squared plus 7x minus 5. So we do this multiplication, verify that it gives us our dividend. Of course, this multiplication would be, we would use FOIL. We would say 3x times 6x, which is 6x squared. We would say 3x times negative 1, which is negative 3x. We would say 5 times 2x, which is 10x. And we would say 5 times negative 1, which is negative 5. And we look to see that we can combine these terms. So our result would be 6x squared plus 7x minus 5, which is our next, which is our dividend. So we know that we did our problem right and our quotient and remainder are correct. Well, it's probably a good idea that you look at the next video, which has a little more complicated example of long division.